Welcome. In this video, we are going to look at problem 45 from chapter 31 of College Physics 2E by OpenStax. In this problem, we have a cobalt source. It's labeled with 4.00 millicuries, but its present activity is found to be 1.85 times 10 to the 7 becquerels. So we need to figure out what the present activity is in millicuries, and then how long ago did it actually have the 4 millicurie activity. Okay, so let's start with what we know. Okay, so we have cobalt 60. We know that the initial activity, so R naught, is 4.00 millicuries. We know the present activity R is 1.85 times 10 to the 7 becquerels. We need to find R in millicuries, and we need to find the time. All right, and then from the OpenStax textbook, table B, so from table B, the half-life of cobalt 60 is 5.271 years. All right, so in part A, we have R is 1.85 times 10 to the 7 becquerels. A becquerel is a BQ. Okay, we can turn this into curies because 1 curie is 3.7 times 10 to the 10 becquerels. But they asked for millicuries, and there are 1,000 millicuries in 1 curie. So this gives us a present activity of 0.500 millicuries. Okay, and so now to find the time, we're going to use the equation R is R naught times e to the minus lambda t. Okay, and lambda, this isn't wavelength lambda. Lambda is the ln of 2 divided by the half-life t1/2. And so let's solve for t, and then we will put the lambda in. So we're going to solve for t. Okay, so the first thing we're going to do is divide both sides by R naught. And so R divided by R naught is e to the minus lambda t. Now we take the natural log of both sides because we're dealing with base e. So we want the ln of R over R naught. That's the ln of e to the minus lambda t. Okay, so this is the ln of R over R naught. And now the ln of e, we can bring the lambda t down in front. And now the ln of e is 1. Or we can just use that, the ln of e to the power is just what the power is. And so we have the ln of R over R naught is equal to minus lambda t. We're looking for t. And so t is going to be the ln of R over R naught divided by a minus lambda. But we said lambda, right, is the natural log of 2 divided by the half-life. So let's substitute that. So we've got ln of R over R naught over minus ln of 2 over t1/2. All right, so let's put in our values. We've got the natural log. R we just found 0.500 millicuries. We're dividing by the initial, which is the 4.00 millicuries. Now we got to divide, then it's the natural log of all that. We got minus the natural log of 2 divided by the half-life, which is 5.271 years. So dividing twice flips it up. Doing all that on the calculator gives 15.813 years. And so we can call that 15.8 years. So that's how it was that long ago that the source had an activity of 4.00 millicuries. Okay, I hope you found that helpful. Let me know in the comment section if you have any questions. Thank you for watching, and I'll see you in the next one.